Good day, ladies and gentlemen. Good day. 5.4. Here we go. Before we do that, let's talk about one more horrible thing that takes place in the world. There's a disease that you guys are all familiar with, but you don't realize how terrible it is across the world because we hear it so often. I'm not going to tell you the name of the disease until at the end of the video to make you think about it. This disease kills one person every 2 minutes. It's not AIDS, so don't go there. Think about it for a second. We'll come back to it. Okay, so 5.4, how do communities and ecosystems respond to changing environmental conditions? Okay, so we're going to be going with succession here in this department. Okay, so ecological succession, a gradual, unidirectional change of communities in a geographical area or a process by which species composition changes through time in an area. So as a habitat changes over time, the species that are in that habitat will also change over time. Does that make sense? Yeah, makes sense. Let's do it. Here is lichen. Lichen is a symbiotic relationship between algae and fungus. Fungus provides structure that adheres to the rock and gives the algae a place to live. In return, the algae is photosynthetic and it gives the fungus some food. So it's a mutualistic relationship. They're both benefiting. What did the male mushroom say to the female mushroom? I'm a fun guy. Okay, so succession. This is what happens. How do we go from bare rock to grasses and shrubs and then trees? So here's what happens. We've got immigration. Something is moving into an area, immigration. They establish themselves, or establish a population in that new area. The site becomes modified because of their existence in that area. Then they compete with each other, which is intraspecific competition. And then they begin to compete with other organisms in the area, other species, which is interspecific competition for resources and space. And then we get to this ecosystem stabilization, where eventually things reach like sort of homeostasis. There's still change going on, but you may not see it as much because there's so many organisms in this habitat that you don't notice change is happening to maybe 1 or 2 species at a time. So primary succession begins on lifeless terrain where there's never been any life before, or it's stripped all the way down to bedrock. For example, areas where there used to be giant glaciers, and if those glaciers melt very rapidly, there'll be nothing underneath them but bare rock, because as those glaciers move, they scrape and rip everything up. Or another example is of new volcanic islands. When the eruption takes place and the magma comes out of the Earth's crust and it hardens, it forms new islands, new land masses that have nothing on them. Secondary succession, repairing of the system after damage. So once something happens and rips up an area, it's starting from an earlier point. Not from bare rock, but from an earlier point. For example, think about the football field that has dirt, it has humus in the dirt, it has organisms, a whole ecosystem in that dirt with everything in there, from the bacteria to the fungus, right? But there's only grass, and that's because we continually go in there and mow it, and that keeps anything else bigger than grass from growing there. But if we step back and let it go, eventually that would become a forested area again, and that is called secondary succession, where mowing takes it back, but not all the way to bare rock. That's really slow. Basically known as old field succession, which is what I just described at the football field. Okay, pioneer species. These are the first things to colonize. They immigrate into a new area and start populating. Great examples of them are lichens, which I introduced in the beginning, and small mosses. Lichens show up first, right? And as they continue to grow and die, they form small quantities of organic matter known as humus, which is what gives that black dirt its color, right? It's the humus, the humic acid that's in there. You see it and you go, that's good dirt because it's black. That's because you're just looking at the humus. Once the lichen make enough of that stuff, then mosses can support themselves, so they'll start to colonize an area. Lichens? Yes. Secondary succession. Usually if you rip something up, the first things to colonize are grasses. because they're small, they make a lot of seeds, they spread quicker, they don't take as long to grow, so that is the pioneer species in secondary succession. There's grass. Okay, so again, where there were glaciers, where there was lava, exposed substratum in the soil layers, meaning the rock. You're ripping everything all the way down to the rock. Proceeds very, very slowly, because now you've got to take this rock, you've got to erode it to make sand particles. The sand particles hold on to the humus, which is brought by the growth and death of the lichen. Then you get some mosses, and then you get some shrubs and grasses. Woo, takes forever. Here's a sequence of events. They're starting with bare rock, the lichens move in, the mosses, then you get your grasses and your weeds, and then eventually you get some shrubs. You get pine trees, because they are you call softwood trees. They grow relatively quickly. And then you get your hardwood trees like oaks, maples, hickory, stuff like that. And this is what it would look like. Bare rock, hardwood forest. Secondary succession, old forest area or farm that is left alone, and it proceeds quicker than primary succession because, again, you're not going all the way to bare rock. You're just going back to the grasses and or shrubs area, so it only has to progress from that point forward again. So exposed soil, so again, you're going right from the weeds and the grasses, then to the shrubs, pine trees, oak trees. So you miss that whole front area that starts with the lava flow and then lichens and mosses. Beautiful. All right. So as succession progresses, soil depth becomes deeper, of course, because as you can add more organisms to that small quantity of humus that was created, and now you can support the next bigger organism or species in that succession, right? Then once they die, they add even more humus, so then that humus layer gets thicker and deeper, so your soil gets deeper and deeper. That makes sense. That makes sense. The plants become taller, right? Because what's happening is there is a competition amongst those species for what can do better and what can get more sun. So you start with grasses and then shrubs, and then whichever shrub gets a little bit taller, that one survives. And then the trees that come in have to get a little bit taller than the shrubs. And then the trees themselves start competing for who can get higher and get closer towards the sun to get their leaves and canopy above the other trees to take that sunlight. Biomass increases, of course, right? Because if you're starting with just bare rock, there's no biomass. But as succession continues to go forth towards that developed forest, the biomass of that area increases. Biomass meaning the actual mass of the living organisms in that area, the weight of the trees, the weight of the grass, the weight of the roots, the weight of the shrubs, all of that. Diversity increases because the more stuff you have in your forest, more species of plants, and then you have more insects, which means you have more feeding predators like lizards and birds, and then squirrels, and blah, 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 blah. You get it. Yeah. The changes, early changes benefit those that are coming down the line. That makes sense. And it eventually leads to what's called a climax community, which would be that stable forest. Ecosystems change, yes they do. Okay, so positive and negative feedback loops. Hopefully you remember that from the vocab words from chapter 2. Positive feedback loops, negative feedback loops, and they work together to help keep that homeostasis in the forest. Persistence is the term that's, I believe, most commonly used, and that is the ability to survive moderate disturbances. So maybe there's a lightning strike and it burns a small area of habitat, which is important. We'll talk about that in a second. The ability for like the palmetto to come right back in, that's persistence. Resilience, once there's a massive act of God, natural disaster, right, and it rips through an area, be able to restore the area quickly through secondary succession. And then tipping point, stresses that cause abrupt and irreversible collapse. Yes, so I'm trying to think of a good example here. In the rainforest, all of those trees process tons and tons of water out of the ground. and it makes that canopy and below of that forest very wet and soggy and moist, because that water is sucked up through the roots, given off or transpired through the leaves of the tree, and then it stays and it makes this little microclimate. So everything below has all the water that they need to survive, because the trees are moving that water and making a little water cycle, if you will, throughout the canopies of the trees and the ground below it. Once we go through and clear enough of those trees out of the rainforest, there's not enough transpiration taking place. The water is completely removed from the ecosystem, and the ground becomes so dry that it cracks, and it's kind of like being bone dry. If you are an art student and you play with clay, before you fire it, you let it really get dry and hard. It's very hard to get water back into that clay, right? Once it's bone dry, same thing happens. You can't get water back into that dirt again, and to get it living and able to absorb it, hold onto the water, and then support life. Fire climax communities. Fire is very, very important. If you talk about pine trees here in Florida, especially the longleaf pine, these trees are adapted to living in areas that have frequent fires every 2 to 3 years. A small fire that moves through. The cones, which is what holds the seeds of the pine tree, will not open and let those seeds out until they reach a certain temperature in a fire, which is nuts. So the seeds sprout after the fires, right, in these nutrient-rich soils. So the fires move through, burn all the underbrush, which then returns the nutrients to the soil, which gives the nutrients to the seeds to now grow. They've got these layered bark on a pine tree. Go break some apart and feel it one time. And as it gets hot, it actually flakes and bursts off. And as that happens, the pieces of the bark that are bursting off and flying off are carrying with it the heat from the fire, and then the bark underneath it is cooler. And then once that gets hot, it bursts off. And there's enough around that tree to survive these frequent fires, and then they get replaced. The roots, the palmettos, they spread roots out everywhere, so that way part of that root system is not going to be tore up by the fire, and then it will, after the fire moves through, repopulate all those palmettos. Frequent fires burn quickly at low temperatures. All right, so low temperatures don't kill anything, or don't kill the pine trees. It removes excess fuel to prevent huge, hot-burning, devastating fires. Removes exotic species, recycles nutrients, and reduces insect populations that may be detrimental to an area. And that's that. So now going back to our little thing here. So if that was 13 minutes. So I can do that in my head, every 2 minutes, so that's 13 divided by 2. So there were, 6.5 people died from that disease during the time I did this presentation. What disease am I talking about? It's the flu. Yes, the flu that we hear about all the time, which is why you're not concerned about it, because it's all over and we hear about it constantly. Kills 250,000 people every single year across the world, which is really, really incredible. That's still that devastating. And that equates to 2 per minute, or 6.5 during this presentation. Have a lovely day.